All right. So we have our second fireside chat for the day. Anna Rose, who is the inimitable host of the ZK podcast and has been absolutely crucial in building out community in the ZK space, will be interviewing Wei Dai, who is a research partner at 1KX and one of the inventors of the Crypto++ library. We're very excited to have both. That's not you?
No, that's not me.
Oh, is that someone else? Yes. Oh my God, I'm so sorry about that. But Wei has been crucial in terms of his contributions to the ZK space, and he is a frequent collaborator as well of RStack. So thank you for that. Please take it away.
Is this on? It's just a very famous name.
It's a long story. I mean, I can explain, but
There is. Wait, isn't it like it's like an OG Bitcoin person?
yeah. So
Yeah.
this other Wei Dai, he basically wrote this TXT file and put it on the internet back in 1998 called B Money, and Satoshi cited his work, right? And that's why he's so famous, and the unit of Ethereum is named after him. But that's not me. I'm the one Wei Dai that's currently active in crypto.
Nice.
That's the short story.
So yeah, Wei, why don't you introduce yourself and share a little bit more about what you're doing generally? I know you gave a short intro, but what are you doing today, and what are you focused on in the ZK space?
Yeah, definitely. So I'm a full-time investor at 1KX. My background is technical, so I did a PhD in cryptography from UC San Diego. And throughout that journey, I realized kind of what I was working on didn't really have too much real-world impact. I was doing security proofs, security analysis of signature schemes, which relates to ZK, but I wasn't really doing ZK or blockchain research. And around 2020, 2021, I really wanted to pivot my research around and to focus on blockchain technology and to things that this new wave of up-and-coming technologies, right, like ZK, scalability, rollups. And I basically just dove head deep into protocol design and learning about everything that's out there, right, for the past decade. And privacy, scalability, rollups, DA, consensus. And through that work, I think I was fortunate to maybe find some new results, especially in privacy, put out some papers, and that led me to a research position at Bain Capital Crypto, where I was just a research partner for a year. And I realized I actually really enjoyed working with early stage startups. Actually, one of the first investments I worked on at Bain Capital Crypto was RISC Zero, who's hosting this event today. And yeah, so now I've been a full-time investor at 1KX for about a year and a half. And yeah, just really enjoying working with companies at the really early stage and finding what's the best way to bring a deeply technical topic to production and actually have utility right on top of a token network.
I feel like you sped run through blockchain and then landed into ZK right when, you're talking, when would you say you actually got into ZK? Is it like 2021? You said you start on this journey 2020. How long does it take you to find us?
Yeah, I think pretty early on,
Okay.
I think because of ZKPodcast, I would say,
Ah,
right? This
no
is,
way.
I
Didn't pay him to say this or anything.
It is one of the first resources, right? That was very aggregated, and I think one of my first experience actually learning what ZK could do was actually this podcast with Diversify. The founder, I remember
With
explicitly
Will.
this. Yeah.
Oh, wow.
This was like an episode I heard, and I think I realized, hey, there's this technology out there that's scaling Ethereum, right? And you can build a DEX, a perfect exchange using ZK, and it has self-custodial properties, and you can compete with centralized exchanges, right? Why is FTX not built like that, right? And I think that was 2020, 2021.
Yeah.
And
That's funny. I'll quickly introduce myself. I know you shared this. So I'm the host of a show called the Zero Knowledge Podcast, which thank you for mentioning. I'm also the creator of a educational hub called ZK Hack, and I'm currently wearing the shirt for that. And then I also have this company called ZK Validator, ZKV, and Will, who you just mentioned from Diversify, then RhinoFi, he's one of my co-founders there. It's funny. Yeah, I want to just very quickly, before we jump into, so basically the plan for this fireside, for this chat, is to kind of do a look over, this ZK supply chain and the different categories that we're seeing emerge in the ZK space. So I'm glad that Shuma, I don't know if you were there for Shuma's talk just now, but he laid out this supply chain. I think we're going to take that, but we're going to extend it sort of from kind of what is fed into it, and then what could be after that part of the chain. I did want to mention something before I kick off, though, and that's just related to ZK Hack. If there's anyone here who's a builder, ZK Hack does hackathons around ZK, and we actually have RISC Zero as one of our top sponsors for the upcoming ZK Hack Montreal in a month. So if you're a builder, just keep that in mind. So I think I wanted to start with kind of your focus today in terms of investment, and then I want to jump into the ZK supply chain and then extend that. So yeah, what kind of things are you looking for right now? What side of it are you on?
Can I talk about things outside of ZK?
Sure.
Yeah, I think if you look at how blockchains came to be, it was really consensus, and Satoshi realizing that proof of work is a way to build permissionless consensus, right? If you look at blockchain scaling or auto scaling, it was really enabled by fraud proofs and ZK, and I think a theme here is really like deep tech, computer science, cryptography topics, enabling new infrastructure, and we're seeing that, for example, with DA, we're seeing that, with auto scaling, like I mentioned, and for me as a deep tech crypto investor, that's what I call myself, it's really what else is out there, what is coming up next. I think ZK is one of the crucial technologies, right? We still yet to realize the full potential of it, but I think there's others, like coding theory or, consensus. We still have yet to really bring out the best of computer science, in a distributed system setting.
And are you looking into like the FHEs and the MPCs, or are you looking at something else?
FHE, MPC, of course, yes.
Okay. What else is there? I'm actually really curious if you see anything else.
Yeah, so one thing, I'm not going to mention the name of the project, but if you look at how we've been doing networking, right? If you look at DA, it's kind of a way to do networking. A full node will pull from the DA layer instead, right? Instead of like doing gossiping. Also, this also relates to this new class of consensus protocols called DAG-based protocols, which basically streamlines mempool replication and consensus, right? And it turns out, like, if you look at Tendermint, right, people use the P2P in a black box. If you open up that layer, there's actually a lot to do, right? If you kind of bring coding theory professionals, things you can speed up.
I mean, DAGs have been around for a while. I remember in 2017 there was a DAG project, but it was like fake.
I don't want to. Can we mention names? No, yeah.
Yeah, but it was like they constantly championed that idea, but then under the hood,
just too early.
Yeah, it wasn't actually working. But that's interesting that you're looking back at that. Okay, so let's start in on the ZK supply chain and kind of revisit what Shuma had presented there. So I think the way that I've thought about this is, I think, Shuma, you called it users, provers, verifiers. And when you think of users, I mean, I was trying to kind of dive into what that actually looks like. So I thought of applications, any off-chain compute, maybe what ZK VMs are doing. Do you think that's correct? Is that the user, usually?
I think usually there's multiple different layers of users. I maybe want to add to the supply chain the notion of developers and end users, right? Maybe there's different layers of developers as well. Like, for example, you could be building RISC Zero, and you could be a developer on RISC Zero, who then serves the end user.
Yeah. So the end user is using the application, the developer's building the application, but all of them in the supply chain are sort of like creating proofs. They're the proof creators. They're not the provers. They're the ones that kind of need the proofs, right?
Yeah, so they generate the demand for proof generation, right? So they're the supply side of why do we need more proofs, right? So users would generate transactions on L2s, right, which then generate proving demand. But those users will not be there unless their ZK rollups build ZK rollups, right?
Yeah. And I think there is often this sort of like supply-demand part between, well, actually, we'll continue on the supply chain, just kind of doing the overarching, and then we're going to get into the nuances of maybe some of the challenges. So the next step was, we're going again, user, prover, verifier. The prover, at this point, it's often these sort of centralized provers, like a roll-up will run the provers that are actually creating the proofs. But there's been this emergence of the proving networks or the proving marketplaces, which is an attempt to, add more agents in there and decentralize and parallelize a lot of the work. What are you seeing on the proving network or proving marketplace front? Because to me, this is like early this year, 2024. That's when we really saw those come up?
I think it's a natural progression, right? We want to decentralize this part of the stack so that we'll have more liveness guarantees, right? If the centralized prover go down, there'll be other people stepping in. But it's also a cost reduction mechanism, right? Because if you look at how mining, one analogy that everybody makes is ZK is kind of like mining, right? So you have networks that demands computation, and it should be done at a place where the cost is lowest, right? And usually this means like hydroelectric dams, places with low cost electricity, places that doesn't need too much cooling, right, for the data centers. I think it is very much a natural progression. There's definitely more complexities to ZK proving compared to Bitcoin mining, which is very, very simple. And ZK proving, depends on the proving stack, which is changing all the time. Most of the stacks today require a particular node configuration. If you look at the Polygon ZK Sync, they really customize their provers for a particular hardware, right? And that's, so in some sense, the demand side is not really fungible, right? And so there's a lot of challenges. We're seeing a lot of interest in the private sector, VCs funding prover markets, or projects that are building rollups, trying to basically launch their own prover markets. A lot of excitement there.
And I think, you just made the comparison, but you made a distinction that it's not like mining, but it sounds so much like mining. It sounds like you need energy, like hardware can help you here. Do you actually see the potential like ex-miners of the POW systems like jumping into this? I don't know if you know anything about what do you even call it? Like the prover industry?
Yeah, I think because of Bitcoin halving and also Ethereum migrating away from proof of work, these miners are definitely looking around. And the one place that they're shifting their attention to is for sure ZK proving. And we're definitely seeing a lot of interest even in them pre-purchasing hardware. And again, I won't mention names, and I think we're seeing a lot of just interest in what this industry could be.
I want to talk very quickly about where this proving even happens. There was a distinction also made in the slide before, which was like there's the client-side proofs that are created, and then there's the server-side proofs. So when we're talking about a prover network, to me, it's always the server-side proofs, right? Like it has to be out in the open, because the minute you use something like this, there is no privacy. It's nothing like, it's not on your own device anymore.
Maybe, but so far, no.
Okay, do you think there could be?
I think if you look at TEEs, that could potentially be utilized, right? But currently, of course, there's no privacy once the proofs are out.
So that's the provers. And then continuing on, and this is what the presentation before was really about, was this verification aggregation. And I constantly say this wrong. It's like verification aggregators. Is that what they are? Are they aggregators? So what is that like? What exactly are they doing? So we've now kind of walked it through. There's the users who are creating the proofs. There's the provers that are generating the proofs. And then there's this idea of like batching it together.
Yeah, I would say this is a necessity of the application category that is rollups or L2s for Ethereum.
Okay.
The fundamental challenge of scaling a blockchain, right? It's a global resource. Like on Ethereum, you have 30 million gas units per block per 12 seconds, and that is a resource that you cannot exceed. In fact, the target is actually 15, not 30. To verify a proof, gross 18 proof, which is the smallest proof known to date, it requires 200K gas. And so there's a limit to how much Ethereum can verify that. So therefore, if you want to put more and more proofs on chain, the only way to do so is through recursive aggregation. And this is something that Shumo just talked about before. And if you look at ZK rollups today, every ZK rollup is actually doing its own proof aggregation behind the scenes. All proofs are really generated by segments, and it's massively parallelizable. And eventually, they recurse that down to a single on-chain verifiable proof. And what these other projects are, like Nebra trying to do is to additionally aggregate on top of that, so that you have even more bandwidth to settle proofs on Ethereum.
Isn't the verification step though meant to be really fast and cheap? Like, why isn't it already kind of cheap?
It is.
Isn't that why people use snarks often? And not Starks, because isn't the verification longer on the Stark side?
Yes. So Starkware for the longest time put the entire Stark proof on chain, by the way, and
Oh,
so
wow.
which was more expensive, right?
Okay.
And I think it's all a trade-off. It's a spectrum, right? Snarks are supposed to be very succinct. However, Ethereum was not designed from the ground up for Snark verification. In fact, I would say if you talk to EF researchers today and tell them to design Ethereum from the ground up, Vitalik had this talk, right? That hey, the L1 should just verify Snark of the VM execution and be done, right? And there's really ways to make Snark verification faster at L1 level, but currently, like at least for Ethereum, we don't really have that, and which is why there's it only supports Groq16. It doesn't have precompiles for other types of Snarks. It only has one curve, which doesn't really have full 128-bit security. There's a lot of subtleties.
And what we were seeing before is that when it comes to the verification aggregators, they can actually aggregate the client side and the server side. Is it different though? Like, would this really be like you'd do something on a device yourself as a user, and then you send off a proof to be verified in this big mass?
Right. So let's dive into the realm of client-side proving, which I think it's super fascinating.
Yeah.
If you look at where ZK was first used in blockchains, it was Zcash. Zcash was the commercial project that stemmed from this paper called Zero Cash back in 2013, right? So client-side proofs was the first use case where ZK met blockchains, and it's for private transactions. And what about today? Well, rollups are like the main place where proofs are being generated. I think client-side proofs are being overlooked. And
is Zcash client-side proving?
Yes.
Okay.
And so because I won't get into the details, but to really preserve your privacy, the proof should be generated client-side.
Okay.
And there could be additional aggregation on top, right? Cool. And this applies to also projects like Aleo, Mina, Penumbra.
Yeah.
So Penumbra actually uses the Orchard fork of Zcash, I believe. I think. Anyways, they recently launched. I think there's a couple of reasons why client-side proofs maybe have not really reached its full potential. The one is that the circuit size for client sides is really limited so far. And the problem is that if you look at Groq16 and this proof system that's being used, or Plonk, they use the memory usage requirement scales linearly in the size of the circuit, right? And for phones, for WASM environments, you have a hard limit on what that is, and that restricts the size of the circuit you can you can do, right? And the functionality you can put into the application. And we have proof systems now that are being worked on now that doesn't have that property, where you can put a lot larger of the circuit client side. So for example, Hero is such a system, Ligatron, which works for WASM. And move to here, sitting in the audience. I think that's a very interesting, exciting development that could really excite more client-side applications. Yeah.
Where does the the hardware conversation so far has been mostly improving? We just sort of touched on it, but is there like a verification hardware component? Do you know?
Verification hardware component. Interesting.
I wonder is Shuma here? No, he left.
Elaborate.
Well, I don't know. Do you need it? I guess not. It's just the verifying is happening in a smart contract, so I guess you would never have specialized hardware for that in any way.
Yeah.
I guess you could create a chain that is specialized.
Specialized in ZK verification.
Yeah,
I think when we talk about proof aggregation, there is a liveness component, right? The notion that there is an aggregator who will for sure aggregate the proofs and put the recursive proof on chain. And it is a dependency for liveness. You could have them stake, and this is what protocols do, right? If the proof is not generated within a certain amount of time, they get slashed. But however, that is additional trust assumption, right, for that proof to get on chain. And you could imagine, for example, a system where every single proof is put on chain. But maybe, if you want to have every single home staker run proof verification, they wouldn't be able to check all proofs.
Yeah.
For batch verification should be easier. And this is maybe diving way into the weeds. There's this new paper recently called naysayer proofs. Unfortunately, I don't remember all the name of all authors.
What's the name?
Naysayer proofs.
Naysayer proofs. Yeah. I've seen this. Okay.
So it turns out for certain classes of ZK proofs, there exists a succinct witness to prove that the proof is false. And so it turns out, so this is, okay, diving way into the weeds, but effectively it's kind of fraud-proofing a ZK proof. And it turns out that you can put a lot of proofs onto a chain, right, like a DA layer, and then you have all these like fraud-proof checkers, like, and maybe the home stakers don't need to actually verify everything, right? If you have a lot of proofs on a layer.
All right. Yeah, it was a little bit of an oddball question anyway. So I think we've kind of covered, at least we've gone over this supply chain itself, but now why do any of this? Like, why is this decentralization? Does it make any sense? Because, I mean, I think especially when you look at like the proving network line, there's been proving networks that have come online saying kind of without a use case. They don't necessarily have the users yet. They're just like, we are a marketplace. And there's others that are like coming more, like the initial product is higher in the stack. So it is like a VM or off-chain compute.
The rollups.
And now they're creating a proving network. So that like, is it going to be that like the user and the prover network are kind of the same, and there's just these siloed, you know, I guess like supply chains, or will one prover network win them all? What about those ones that have no use case? These are the things I'm thinking about, because like I think that it really just emerged end of last year, the idea of like a proving network or a marketplace, to me at least. Like that's when I started to see it, and it's still somewhat unproven whether that gets the volume it needs to be economically viable.
This is a really, really good question, and maybe one of the questions that keep me up at night, right? How the space is going to evolve. And as an investor, these are the things that we constantly ask ourselves, right? And I think there's multiple angles to look at this, right? The first thing I would say is that the networks that actually generate the demand are in the strongest position to build out such a network. And I think because supply side is of proving, right? It's really elastic. And we're still trying to onboard more and more ZK proving demand, right? And as ZK rollups gain more adoption, there'll be more proving demand, and they might be in the best position to launch something and start to capture that network effect. And I think, but this is not to discount the fact that the ZK VM project, like RISC Zero and Succinct, and can really push up that 0 to 1 really quickly because of the fact that you can onboard so much compute onto it very easily. But however, I think on the supplier side, it is a little bit tougher to see a moat, right? Like, let's say if you are providing these compute capabilities, they're more like miners, right? They really have to specialize, and for each type of demand.
Do you think that the prover network becomes a hardware company then, or like does it have to have sort of a hardware side?
Yeah, I think so. There's
like the ones that are just purely prover.
Yeah, so there's one camp of thought, which is that there's going to be supply prover networks and demand prover networks.
Okay.
Is this your first time hearing about this one?
Yes, it is. Yeah.
Yeah, and so the supply networks are kind of like people that specialize in GPU. So for example, the Z Prize winners like Snarkify and like what's the other project? Sorry, forgetting what the name. Supranational, exactly. Super specialized in like making better GPU kernels, or maybe people that actually specialize in making hardware, like Ingoyama, Fabric, Sizik, right? Or people that buy these chips. That's the supply side, and the demand side is the RISC Zero, Succinct, L2s, right? Wow. And then they will kind of like match like our type graph.
Interesting, 2 parts to the same network, I guess, marketplace. So yeah, kind of going back to the meta question here is like, why do any of this? Why do we do this? Is it actually lowering price, or is it overcomplicating things? Does it make it stronger, or does it make it more like, is there more bugs introduced or more potential like mistakes?
Yeah, this is a very packed question. I think really the end goal is to provide a better user experience, right? Make better applications, make it faster for devs to use ZK. That is always the end goal. And really the marketplace, should really fit in the background, I would say. Nobody think about Bitcoin mining, for example. And I think actually on the point of bugs, and it is really making the system more complicated. And this is actually a feature for ZK, right? Where all you had to audit is the supply chain on the engineering side.
Okay.
Meaning that if you audit the circuit, which compiles to like the verification key and like underlying cryptography, what you do on the prover side doesn't actually matter, because all you have to have the guarantee of is that my verifier is sound, like the system is sound, and if the prover cheats, the verifier will say no.
Okay, because
And
there's a check built into this.
Exactly, and so you can have these ASIC chips or GPU acceleration, right, just going crazy with optimization. As long as the proof verifies, we know that the system is secure.
Wow. That's
ZK.
interesting. ZK, nice. I think we have 5 minutes left. We could open it up to questions if there are any. I have a few other things we could talk about too, but I don't know if anyone wanted to jump in and ask anything about what we're talking about.
Yeah, thanks for the invite. Not sure if it was mentioned, because we were talking about outsourcing proof generation to the servers, which obviously would leak any privacy. Maybe coming back here, we have now this thing of collaborative snarks, which enable us to still outsource, but not to one single server, to multiple provers. We could still preserve privacy, but also outsource proof generation. So maybe
Oh, interesting. Yeah, I think you had mentioned TEE is used, but is this something else? Is this just cryptographic?
Yeah, so collaborative snarks is basically a branch of MPC, right, where the prover, instead of one server, it's a group of servers running MPC to generate that succinct zero-knowledge proof. It's a very, very fascinating research area. There has been a lot of improvements. However, I think there's still a bottleneck on the communication. For all the papers that I've seen, it's kind of this asterisk that basically the client has to communicate a lot with the server that's running this computation. And I just have not seen a practical benchmark yet where this will actually help for a client-side proof. But the only reason why you outsource this is that you cannot do it client-side, right? And you want the server to assist. And it seems that it's a bandwidth versus local compute trade-off. But yeah, very, very promising new research area.
If there aren't any other questions, I think what we could do is talk a little bit, since we wanted to map out this landscape, we talked a bit about the applications, but we didn't really tease them out. So or the user rather, there's like the application, the roll-up, the coprocessor, the VMs, but then there's also kind of these new emerging use cases, I think, like the ZK-TLS.
ZK email.
ZK email. What else do I have on this list? There's actually some like interesting middleware projects too, like Clique, like this kind of like aggregation of where things should be going. Yeah, there's a few cool, some cool things happening on the application front. Actually, I wonder, like, would a ZK bridge also fall under this?
Yeah, I would say so.
Yeah, that also could be included. So let's explore those. Let's like talk a little bit about each one of those and maybe where they're at. ZK rollups, I think, are super well determined. We know what they are. They have volume. They're real. Do you think that the rollups will ever really want to work with a decentralized prover, though?
I think so.
A prover marketplace.
Yes, I don't see why they would not, actually. Right? If it's cost reduction for their users, better liveness guarantee.
Yeah. They don't make any money on doing the proofs themselves, right? It's the sequencing. Like, there is a fee charged somewhere in that flow, but it's the proving itself. Yeah, do they...
Yeah, sequencing, MEV extraction, fees for a market that has congestion is really the way that the sequencers make money, not the ZK proving part, right?
Okay, so like pushing off the proof seems like something.
Yes.
Why not? The coprocessors. I mean, are the coprocessors that you know, are they actually moving towards building their own prover networks, which I know a few are.
Yeah.
But are they all doing that?
Well, I can't say all unless I chat with all of them and confirm, right?
Okay.
But I would say the ones that I do know are thinking about this.
They are kind of moving in that direction. Because in a way, like, wouldn't it be better if they partnered with an existing one?
Yeah, this is
This
maybe
is what I was
outside
talking
of
about
my
with this.
expertise. But yeah, I mean, who's going to be the network, right? This is a really a question to think about when you're a ZK project. Do I opt into someone else's network, or do I try to make a new one, or does my network plug into their network? Maybe we'll have this layered approach, and I think it's not really a technical question at this point, but more so of like who has like a bigger ecosystem and who has like the network mode.
Then we have ZKVMs, which I think are in this very similar category to the coprocessor, where there's like a prover network or marketplace that's being created as well. But could ZKVMs find another place? Like, is there a fee that could exist and then work with an existing one?
This is a great question, and maybe I have a controversial take. I think ZKVMs are open source software, and they have been. And I compare ZKVMs to, for example, Chromium or Linux.
Okay.
I think, and I would say the builders in the space would agree. It is public goods, open source software that everybody can benefit off of. If you look at ZK rollups and coprocessors, they're networks, right? They have nodes running, like, there's the notion of supply demand, like there's canonical chain or network. But ZKVMs is a technology stack.
It's like a general purpose computing environment.
Yes.
Yeah.
And I think that makes it very, very different, right? And it is a different class compared to like these networks that may eventually one day have a token where you have customers. Yeah.
And then we started to touch into these like, I think I covered this. So it's off-chain compute and the coprocessors, ZKVMs. Then there's these sort of unusual new cases, and I guess a lot of these fall under the client side. I think, like actually ZKTLS and the ZK email, are those considered client side?
Ooh, maybe
I don't
both actually.
No. Yeah.
It's maybe a bit of both.
Okay. Well, I've just been notified that we are also at time, so unfortunately we don't get to dive into that part. But thanks for having this conversation.
It was really fun. Thanks for all the great questions.
Yeah, thanks for listening. Nice. Also, if it's okay, I'm just going to again plug ZK Hack Montreal, because you guys we're working together on that. So this is in a month. Are you coming? ZK Hack Montreal, August 9th to 11th in Montreal, and it's a hackathon. And if you want to build with the RISC Zero stack and some other great tools, check it out.